So today we're going to be talking about some best practices for network design and deployment. So the objectives of this session are to understand the importance of the industrial network infrastructure, understand the life cycle, including the assessment, design, and deployment, best practices for deploying these networks. We'll also be talking about our partner ecosystem. So when I'm presenting the solution, this is really best practices garnered from my experience and work here at Panduit, and we hope that you'll find this to be very educational. We'll provide you some resources so that you can emulate the characteristics of the solution set as you need to, and hopefully we help kind of change the tenor and nature of this business and move the infrastructure design and deployment to kind of a new level. So the first thing is to understand, the importance of the physical infrastructure and network deployment. And to do this, I really look at the growth of IoT. We can see that there are a lot more things being connected to the networks. There's a lot more information that is being connected through the IoT. In the consumer world, there's lots of devices like the home security, thermostats, health monitoring, even garage door openers, coffee makers, etc. In the industrial world, we're seeing a similar explosion, and this is related to some of the wireless sensing devices. The industrial automation control systems are now leveraging some of these wireless devices. We've got many different types of sensors that are now providing real-time information to dashboards and to people in manufacturing on their smartphones. So right now, we're expecting that there'll be 50 billion, that's billion with a B, smart objects that are going to be out in the industry by 2020, and that's about 6 times greater than the world's population. So this is becoming a real big trend in industrial networks, and there's some other trends that are taking place too to support this. So one of those is the migration from a switch-centric topology. So we're migrating to this switch-center topology instead of having a controller or a PLC type central topology. We have a lot more data that is being put onto these networks, and it's starting to stretch the limitations of the legacy networks that are out there. We're moving to more of a standard base. The industrial Ethernet is really enabling some of the IT solutions to now be used on the plant floor. And of course, all of this is now providing some real-time analytics. Now, this is also providing us a challenge too, because we now need to be able to connect to the factory floor and boost our productivity throughout the whole enterprise. We've got 2 important statistics here related to IoT, and so 95% of C-suite executives expect that they're going to be using IoT in the next 3 years' time, and 63% of them believe that those companies that are slow to integrate IoT are going to fall behind the competition. So we'll come to our interactive session here, and we will go to the first poll question.
All right, Jim, I went ahead and launched the poll questions. We'll give you just a couple minutes here to go ahead and answer the question. Okay, Jim, it looks like we are completed here. I'm going to go ahead and close out the poll.
Thank you. So one of the first questions we want to ask everybody, when they're talking about using networks in manufacturing, is how dependent is your manufacturing on the network? So we have a number of questions here, and basically if you answer no to any of these questions, then your manufacturing there is very dependent on the network. So, it's very important, to understand that for manufacturing, you can't ship product a lot of times if you don't have the regulatory information, on the product that's being shipped. So the network is very, very dependent, or the manufacturing is very dependent on the network being live and functioning. So one of the things we see is a lot of very poor infrastructures, and these are some examples of the networks that we see out on the manufacturing floor. And a lot of these things are just caused because of poor housekeeping, expansion of networks without a real good plan. And what ends up happening is you have poor cable management, you have identification that's missing on the cabling itself, there's grounding and bonding issues, and many issues where the network is not really up to the standards. It's very important that we understand that the infrastructure that we're putting in is going to have to outlast a lot of the other manufacturing aspects. So the hardware that we deploy, the network switches, controllers, devices, typically we will have to use the same infrastructure and replace that hardware 2 times. And the software that's used on the network, such as the data historians, OEE, and other types of HMI software, etc., all that's going to be replaced 3 times over the course of the network. So the network we're putting in right now is very important, and we need to make sure we have the proper planning, we do future proofing, make sure we do capacity balancing and things like that when we're putting in the network. And the last statistic here that I like to point out is that 70% of the network failures are attributed to the physical infrastructure. So again, highlighting the importance of taking some care when we put in the infrastructure, because it's going to have to last us for the next 25 years. With that said, we also want to, discuss with our clients and customers, and also take a look at our own, manufacturing capabilities and determine where we are kind of in this continuum. We call this the network fabric maturity model, and it goes from being very restrictive, where you've got many OT, many operational technology networks, and very little convergence. You've got sprawl of the networks, you've got islands of automation, there's no real strategy, and there's really no security that's provided in that scenario. And then we move into more of the functional area, where we have OT, physical convergence, and this is where we're going to be using the common network throughout the OT area. We're going to use some standards. We're going to make sure that we're using similar technologies throughout, and this is going to help us with the security. It's going to help us provide visibility. It's going to help us provide information throughout the OT area. Then we move into area 3, which is where we're going to converge the OT, the operational area, and the IT networks. And so this is something called CPWE oftentimes. And so this means that we're going to be using similar technologies throughout our entire enterprise. And so this is going to allow us to virtualize some plant applications. It's going to allow us to leverage a lot of good IT standards. And it's also going to help us be able to propagate the data throughout our network, turning the data into actionable information. And also is going to start providing us with a much tighter security throughout the network. Our vision is to move into this network fabric emergence. This is the innovative phase, and this is where we're going to be using a fabric approach for both the wired and wireless infrastructure. We're going to be, moving the IoT and combining that with our typical OT and IT. So this way we have a scalable technology. We're going to be able to deliver on the edge computing, video, cloud service, etc. throughout. And we're actually going to be able to start using our network as a way to actually drive some business value that we never were able to before. We're going to be able to do some predictive and hyper awareness of the network health, and we're going to be able to plug all those security holes as well. So that's the network maturity model, and most customers find themselves somewhere between 1 and 2. Some of the more progressive manufacturing plants have taken advantage of the CPWE and are over in level 3, and some are now pushing that envelope and moving into the network fabric emergence stage. So this now tees us up for our second of the 3 questions.
Okay, Jim, I'll go ahead and launch the question. Give a couple moments to answer the question. Okay, Jim, I'm going to go ahead and close the question.
Thank you. So now let's move into some of the best practices we have for our networks, and I break those down into 3 different areas. One of them is doing assessment, design, and then deployment. The assessment area is being able to take a good audit of what you have, how your networks have been deployed, looking at some things such as your capabilities to withstand thermals, looking at maybe grounding and bonding, and being able to basically map your entire network and understand the devices and capabilities that you have on your network. So that's all under the assess pillar. The design is really doing that physical infrastructure design, and we'll show you some of the best practices for that design. And then deploy is then being able to ensure that the things were designed are actually deployed, that the design intent has actually been put out in the field, making sure that you've got good documentation, traceability, and supporting management of the network in the future. So that all falls under that deploy pillar. So let's talk a little bit about some ways to do the network assessment. So when we do the network assessment, one of the things we'll do is we'll do an industrial network mapping and evaluation. So that means collecting a list of all the devices that are connected to your network, and we use a tool to go out there and do that discovery, do that mapping automatically. And so that'll show us how the network is physically connected together. It also will show exactly which port is connected to which device, and will give us a list of all the devices that are on our network. We'll have the network field names, and then also with that discovery we can look at the bandwidth utilization throughout the network. So we can look at the overall capacity and capabilities of our network. We can see if there's some devices on there that are hogging a lot of bandwidth. We can see if we've maybe got excessive traffic due to propagation of unmanaged switches and things like that. And so being able to have a tool like this really aids us to identify what we've got deployed out on our network. And then we can use that information to then evaluate against some different areas. And in this case here, what we've done is we're showing the 7 different areas, functional areas, that we evaluate the system, looking at the racks and cabinets, cabling, labeling administration, pathways, the power to all the racks and devices, the grounding, as well as thermal performance and airflow. So we'll go on and do that audit. Now, when we're doing this type of evaluation, we're not using our opinion, but we're actually evaluating this against the applicable industry standards. And so on this slide here, we've shown some of the different standards that are being used. There are some common standards which are provided to us by ANSI and TIA. And then for the OT side of things, there are some standards, the 1005, which are industrial standards that we utilize. And then there also are some component standards that we need to follow. And that'll tell us about, the performance capabilities, architectures, methods for termination of our copper and fiber network, and how to address each of those elements as far as deployment and the types of testing that is required here to meet the telecommunication standards. So one of the best practices I'd like to highlight is the utilization of the TIA standards. If you haven't had a chance to explore some of those, you can, this is a good opportunity to look at the standards and then look to see how you can leverage these standards in both your assessments as well as moving forward into your design activities. One of the other important things to look at is how the networks are segregated. And we like to utilize a system called CPWE. This was something developed by Rockwell Automation and Cisco. And Panduit has now been included in the latest revision of this as part of the physical infrastructure portion. The basic framework is from the Purdue model for a control hierarchy. And we have some different levels here going from the enterprise, then going to the industrial demilitarized zone, and to the industrial zone, and then to the different levels at the plant. One of the things is to utilize a best practice. If you've got a network of significant size, putting in an industrial DMZ to segregate the traffic between the enterprise and the industrial side is recommended. If you've got a very small deployment, maybe using VLANs is acceptable as well. But if you've got a medium to large size deployment, we really recommend utilizing a DMZ type approach to make sure that you're segregating the traffic from your enterprise and not having that affect your controls operation. At the level 4 and 5, down at the bottom, we depict a couple of different architectures. We have a redundant star, we have a ring, and then we have a bus type methodology. So these are the 3 different types of network topologies that we'll be utilizing. So going into a little bit more detail on the CPWE, we've kind of broken down some of the different areas. For our solutions, a lot of times we'll be doing a plant-wide enterprise type configuration. So we'll be using pre-configured integrated solutions there at the enterprise level, and then moving into the micro data center, industrial data frame for the communications between the enterprise and the plant floor. And then for the industrial distribution, where we have a real high density of devices, we show using a distributed type solution with the network zone enclosures, and oftentimes going into the control panels themselves. So as we walk through there, we'll have the enterprise cabinets at the enterprise level, and then we'll use the micro data center and the industrial data frame here at the mid-level, and then using the network zone enclosures or the control panels at the lower level. So we now have these building blocks that we'll be utilizing, and using these building blocks allows us to deploy things very quickly. It helps us provide rapid designs, and these are proven architectures that we can move forward, so we know that we've got a robust solution that we're designing around. So what we really talked about here is the physical. To really do a network design, the best approach is there is a logical component as well. So we always have, the logical piece and the physical piece. And the logical piece, this is where we really turn to the CSCI partners. And they're the people who can help create that logical architecture. And then we'll, using this the Panduit One type solution, either through Panduit or some of our Panduit One partners who've been trained on the physical design and physical deployment. They can then take that logical design and translate that into an executable, buildable design using some of these the building blocks that we just discussed on the previous slide. So going into the logical design itself, there's a number of elements in the logical design, and these are things that the CSCI has some good practices, and I know you guys are pretty familiar with being able to develop the block topology, the switch topology, selecting the different types of network devices, and then also providing the overall network schemas, the VLANs, the names, functions, the IP address, and then coming up with the switch configurations, those command line instructions to help deploy the network. So those are all the elements of the logical design. And then we'll take those building blocks that we showed, through the CPWE model, and then we will, create the physical design. Now we'll have to consider some things such as, the distances involved there. That will, dictate the types of media that we'll utilize, the environmental conditions. Something called MICE, which is an acronym for mechanical. I is for ingress, C is for chemical climactic, and E is for EMF. And so we'll look at the levels of those environmentals for the MICE to help us determine the proper product selection, as well as the way that we'll actually do the design implementation. Of course, we'll be using a structured cabling approach, using switch convergence to help us deploy. So let's now look into the constructible methodology that we use. And so one of the other best practices that I'd like to identify is utilizing the CSI type methodology. CSI stands for the Construction Standards Institute. So combining the CSI Construction Standards Institute along with TIA is really the cornerstones of the solution we're showing here. And we think that this is really a best practice. The CSI standard is really an architectural standard. So when you design your telecommunication elements, everything will fit into that standard architectural package. So we will do this in 3 phases. The first phase is just the planning. It's identifying the requirements, setting up the different functional areas, do the high-level space planning and connectivity. And then the second phase is getting into the details, looking at the individual racks, the cabinets, going down into the ports, going into the details that are needed to, specify all the cabling that's going to be run. And then we hit the phase 3, where we provide a cable schedule, the bill of material, and then a specification package that then explains exactly how this network is going to be implemented. And so the specifications are done on a project basis. They are not generic. They actually, address the key elements that will be coming up through the design. So a lot of words there. Let me show you some pictures. And I think this will help, explain the methodology a little bit better. So our phase 0 is really defining the what we're going to be doing, via a statement of work. And then once we start the project, we'll move into the how, and that's what we call a program report. And so the program report is going to be the technical performance expectations and functional requirements. And all this will be done by meeting with the owner to determine the requirements, walking their facility, looking for, any requirements, and then identifying the type of solutions can be needed. So it'll go down to the level of showing the cable media selection, the topologies, redundancy requirements, looking for available pathways, looking for the locations that we're going to be putting all the components. And so all of that gets described in words in the program report. Then we take that program report, and I'm going to kind of walk through the different elements here of phase 1, starting in the upper right. And so we start with a one-line diagram. And so the one-line diagram shows how the different devices are going to be physically connected. So it's going to show also the media that's going to be used to connect the different devices, all at a high level, so that we have a nice organizational flow. And we'll be identifying, the enclosures, the cabinets, etc., on this one-line diagram. And then we'll be going into the details of where those devices are going to be located by moving to the left. We're showing in the room where we're actually physically mounting the racks and cabinets. And then moving farther to the left, we're then going to show where those locations are going to be within the plant floor. And then we'll also show the proposed routings of how we're going to connect all those devices together. So basically taking the one-line diagram and now putting it onto the plant floor. And just two different examples of that here. So after we've now identified all the devices, all the locations, and basically how we're going to wire them up at a high level, we're now ready to move into the more details. So the details are now going into the switch elevation views. And we'll be showing all the devices and where they're going to be located in the rack, or if it's in an enclosure, we'll show the patch panels and the switch locations, and then get down to the port level. So each port will then have a certain label associated with it, and then we'll be referencing that port position with our cable schedule. So we'll come up with a way of identifying every single wire that's going to be placed. So this way you understand when you grab a wire out in the field, it'll have the from and to on the wire itself, so you know exactly where and which port the wire is going into. We also show some typical details of how everything gets mounted. and as well as how the grounding and bonding needs to be deployed. All that goes together along with a cable schedule. And so the cable schedule shows you every cable that needs to be run. It's going to identify the pathway that's going to be running in. It's going to identify the label. It goes on the from and the to, the number of strands, the type of media, etc., as well as the part number of the cable. So this becomes a nice checklist for going ahead and developing a bill of material, and also is very useful out in the field. Becomes your checklist to make sure that everything's installed as designed. So all this now gets combined together into what we call a final documentation package. So this is a construction package. It's going to consist of all the elements we just talked about, as well as the specification. And so the specification is a three-part specification. The first part is the general. It talks about the requirements, the type of documentation that's going to be needed, the capabilities and background of the installer, the minimum requirements they need to be able to meet. The second chapter then is how you handle the materials, how you're going to receive the materials, what you're going to do when you're putting up the materials. It'll go down to the detail of saying, this is the spacing that we need to achieve to support the cable between the MDC and the IDF, identifying that we'll be using, for example, non-continuous cable supports like J-hooks, things like that, and the spacing requirements for all of those, as well as methods for maintaining the bend radius, how you're going to handle the fiber, and things like that. So all that's in the middle chapter. And then the final chapter is then the testing requirements and the documentation requirements, so that it'll specify the type of test that is needed, as well as the information that needs to be collected, so that you get the warranty as specified by the cabling manufacturer. Now, this is the final design, so this can now go out to bid, and then once it's been bid, we get into the installation phase. And so one of the best practices that we've come across is ensuring that the deployment is overseen by an RCDD. Okay, and so that as a BICSI certified RCDD will be there, and he'll making sure that everything is installed with the design specifications. What we will typically do is have that designer of the system be there at the kickoff meeting, and so he'll walk through the solution with the designers, or the installers rather, and then we'll come back about the 50% completion stage to make sure that everything is going according to plan. We'll develop a punch list and remediation steps that need to be achieved at that 50% level, and then we'll come back again at that 90% level to make sure that everything has been installed, per the specifications, making sure, acting as an owner's rep to make sure that all the standards have been achieved, and then also making sure that all the as-built documentation, etc., is been provided. So with that said, I think we're now on to our third poll question of the three.
Okay, Jim, I went ahead and launched that. We'll give a minute or two to answer the question. Jim, it does look like the majority has voted, so I'll go ahead and hand it back to you.
Thank you. I'd like to now go into some case studies, or at least a case study that we've put together. And so the case study really is showing how the system integrator community, as well as the installers and also our distribution partners have all come together in what we call the Panduit ecosystem to deliver value to the end user. And by aligning these three elements, and using the Panduit One Partner Program, we use this to deliver value and to actually design and install the complete solution. So oftentimes, we'll be notified about an opportunity, a new project through our distribution partner, and it's very important, that we utilize them to throughout the whole project. And this is a project I like to talk about is one called Noosa Yogurt. Noosa Yogurt, if you haven't tried their product, it's a delicious yogurt. It's from an Australian company who decided to put a green field in the Colorado area. And just to call out the some of the challenges, this was a greenfield expansion project they were working on, and they needed to have a hardened network, something that was going to be well documented, secure. This does deal with food products, and so they do have regulatory issues they need to be able to comply with. They also were going through a great deal of expansion and knew that they had to be able to address future capability. And so bringing together this ecosystem, we were able to deliver a solution to Noosa Yogurt. It was a combination of, the controls were with Rockwell Automation and the network was with Cisco. Panduit did do the initial physical design, working with Rexel, and all of this was orchestrated by Melisco Engineering. So Melisco Engineering really was the the lead on this, and they were also doing the controls activity as well. So they had a great understanding of the requirements and needs, and working with the ecosystem, and then bringing in Piper Electrical to do the final installation. It was a very successful project, and so this is a good illustration of that ecosystem working together the way it should. And I just can't say enough about the CSIA certification and the types of SIs that are part of CSIA. So that kind of brings us to the end of our presentation. I wanted to bring up just a quick slide here of mentioning that we do have a number of resources to help you with these best practices, and I've included some links here. The CPWE is available at the Rockwell site, and we also have some e-learning that's available through ipadvantage.org. And then at Panduit, we have some of these reference architectures depicted in what we call popular configuration drawings. And so this will, help show you some proven architectures and the building block approach that we talked about. So with that said, I'd like to now open this up for some questions.
Thanks, Jim. We will use this time to answer questions. Please feel free to submit your questions utilizing the chat box on the GoToWebinar app. We will answer as many questions as we have time allowed. All right, Jim, it looks like I have my first question here. As part of the industrial networking trends, you mentioned that the migration from a switch-centric topology, what benefits do you see arising from this trend?
Well, yeah, so we're moving more to a switch-centric topology. One of the big benefits is that the PLC used to act as a firewall, preventing information flow, restricting the information flow, And this was needed because a lot of the PLC networks were proprietary and had limited capability at the time. Now that we're moving to Ethernet IP, we have a great deal of bandwidth capabilities, and so we no longer need to have the PLC as the center of the universe, but we can now move the industrial switch in there. And so one of the big advantages is if you needed to have information sent from a limit switch or device up to the information system, to the MES level or SCADA system, you had to programmatically allow the pass of the data through the PLC. Now with the switch now connecting directly to the device, and then the PLC coming off of the device, and then also the MES information being transmitted right through the switch, this no longer is required. So we can now have direct information, and the information can be shared with any device within the facility that needs it. So you may have multiple devices who would need the data from a device on the plant floor, and now they can share that seamlessly, and you don't have to do it programmatically. So this really allows us to expand much faster. It enhances the scalability, and it is allowing us to deliver the IoT type fabric approach that we discussed as well.
Okay, I do have another question. It's actually a couple questions here. Do you see any risks of merging the business, operational, and security networks together? Could these type of networks coexist on the same switch or leveraging common media?
Okay, so this is a trend that we're seeing actually going the other direction. We're finding that, well, initially people said, let's do convergence and let's put everything all in the same network and we can combine it all together. What they've now discovered kind of as a best practice is really we should segregate those networks. And to think about this, we've got operations taking place on the plant floor. We've got safety issues taking place there and data. Last thing we want to do is on the same wire and same network be putting an operator who's searching the internet. We want to really segregate and get that office traffic off of our OT network. So we're really seeing where the segregation is being utilized more and more. And there is a cost and benefit that have to be weighed here. As you move from kind of the medium to large size plant, we really recommend that not only do you not have the same devices connected to the enterprise on the same wire, but we actually suggest you move it to where you put it in a different switch, or a lot of times in a separate cabinet. So we'll be moving, actually segregating the business, the security, the operational technology, the OT networks, onto their own network switches in a lot of cases. And that makes sense too, because we're going to have different people maintaining those. We'll have the OT maintenance people maintaining the OT side, and the IT will be supporting the voice over IP and the voice over IP paging systems and camera systems and things like that. So we'll have different people who need to get access to these different areas. So I think as we progress, we're going to see more and more divergence of having the OT and IT networks coexisting, and more segregation of these.
Okay, looks like I have one more question. It says, typically our physical design would consist only of identifying switch locations, MDZ, and ZE on site drawings. In your opinion, is this sufficient? Is the cost justified to generate all these additional drawings and specifications?
Great question. And so, you know, again, I'm showing a best practice, and this is a very complete solution. And certainly it is something that would, you know, make the maintenance in the future much easier. It really depends on the skill level of the SI and the installer and the end user with this type of approach. What we find is that you know, if you do multiple sites, and as a customer learns more and more, you know, these designs come together very, very quickly. And so I would say that you know, going down this venture may be a little bit more costly on the first go round, but as they start adopting the standards and the methodology, I think that actually you get a lot more benefit, and these solutions go together very quickly. Now, you mentioned about just having a core level, and so if you go back to, you know, the slides I showed, we had a three-phased approach. Essentially, what you were suggesting was that we only do phase one, and we don't do the design for phase two. What I guess I would say is certainly that could be done, but my recommendation is that somebody still needs to do a complete cable schedule. Somebody still needs to identify all the ports and locations and come up with the overall identification scheme. So certainly there's a number of PCIs who have RCDDs on staff, and so that could be done as part of the installation. So my recommendation would be, no, don't cut corners. You need to have all the elements. However, it may make more sense to maybe, you know, divide and conquer and move the responsibilities to the different parties to make sure that you still have that documentation. Remember, you're going to have this network around for 25 years, so you want to make sure you do a real good job of the installation and documentation. We all know that networks are never static, right? There's always going to be changes, moves, adds, etc. on the network, and so starting off with some real good documentation will prevent some of the network sprawl that we see and the lack of housekeeping and things like that. So I really recommend that you start from the get-go with a real tight package, make sure that all the standards are met, so that you can maintain that network for the next 25 years.
Okay, Jim, thanks. It looks like we have time for one more question here. Past enterprise physical design topologies were very simple. Home runs back to an IDF or data center. Is this hierarchy approach adding extra complication?
So I believe the question here is really looking at the overall value of having a distributed network solution. And I would say let's go back to the early days of controls, where, you know, before we had remote I/O and things like that, we did exactly that. We ran home runs back to the PLC, and we had mezzanines that were full of control panels, all lined up one after another. As in the control industry, we discovered that by putting the I/O closer to the machine elements, distributing that I/O, that shortened the amount of cabling that we needed to use to the, to get to the PLC. So we just have a short run going from the device to a cabinet remote with the remote I/O, and then we'd have one cable that connects the remote I/O back to the PLC. And that saved us a lot of costs, it saved us a lot of real estate, and actually allowed us to scale and deploy much easier. So the question you mentioned there sounds very analogous to me to enterprise areas that are used to running home runs, directly to the RJ45 port in your cube, and then we're proposing they move to a distributed type solution. Certainly at the low end, if you've only got a handful of drops, it's very, very simple. Yes, home runs are fine. As soon as you move into a larger installation, I think you'll find the benefits of a distributed architecture will outweigh the costs. And then also it gives you so much more flexibility. So I would really only ever recommend that you do the home run methodology if you've got guarantees that you're really not going to be doing any expansion. Because having distributed architecture, whether it's in the enterprise or whether it's like the CPWE depiction we have there for the plant floor, really makes a lot more sense, especially if you're going to have to add functionality and capability in the future. And the way things are growing, we know that additional capability is most likely going to be needed.
Okay, it looks like we are out of questions and out of time.